Have you ever wondered how the universe, our grand cosmic home, might meet its end? In the vast expanse of space, three possible finales echo through the cosmos: the Big Crunch, the Big Freeze, and the Big Rip. Each one, a unique dance of matter, energy, and time, could spell the ultimate destiny of everything we know. Unfathomable, yet undeniably fascinating. So, let's plunge into the abyss of cosmic possibilities and explore each of these fascinating end scenarios. First up, we have the Big Crunch. Picture this: the universe in all its astronomical grandeur is not continuing its steady expansion. Instead, it's slowing down. The galaxies, stars, and planets start to reverse their outward journey. This is not science fiction, it's a theory known as the Big Crunch. In this scenario, gravity, that invisible force that keeps our feet on the ground, takes center stage. It's gravity that may one day halt the expansion of the universe and cause it to collapse inward. The universe, which has been expanding since the Big Bang, would start to contract, with all matter and energy eventually converging into a single point of infinite density. Just as a heart beats, expanding and contracting, so too might the universe. The Big Crunch theory suggests that the end of our universe could lead to the birth of a new one. If the universe is cyclic, the Big Crunch could be followed by another Big Bang, kickstarting the whole process anew. This idea of cosmic reincarnation is as fascinating as it is terrifying. However, the Big Crunch is not a foregone conclusion. The theory relies on the universe having enough mass to generate the gravitational pull necessary for contraction. But observations have shown that our universe may not be heavy enough to meet this requirement. Yet the universe is full of mysteries, and dark matter could potentially tip the scales. It's also important to note that the Big Crunch, if it were to happen, won't be for billions upon billions of years. So don't cancel your weekend plans just yet. In the grand scheme of things, the Big Crunch paints a picture of a universe that experiences birth, life, and death, only to be reborn from its ashes. A cosmic phoenix, if you will. It's a dramatic, fiery end followed by potential rebirth. So, the Big Crunch. A dramatic, fiery end followed by potential rebirth. But what if our universe's fate is a little colder? Now let's chill things down a bit with the Big Freeze. Imagine the universe continuing to expand, unfettered and unending. Stars, the glowing beacons of heat and light, slowly exhaust their nuclear fuel over trillions of years. One by one they burn out, their brilliant light fading into darkness. This is the scenario envisioned by the Big Freeze, a chillingly cold and dark end to the universe. But why does this happen? The answer lies in the laws of thermodynamics. The first law, the law of energy conservation, states that energy cannot be created or destroyed, only changed from one form to another. The second law, however, is the one that spells doom for the universe. It states that in any energy exchange, if no energy enters or leaves the system, the potential energy of the state will always be less than that of the initial state. This is also known as entropy, or the degree of disorder in a system. Over time, as stars burn out and the universe expands, the total amount of usable energy decreases. Eventually, the universe reaches a state of maximum entropy, where all the energy is evenly distributed and no work can be done. This is the concept of heat death. A universe so uniformly cold and spread out that no life, no processes, no change can occur. In this scenario, the universe does not end with a bang, but with a whimper. As the last stars flicker out, the universe becomes a vast, dark, and unimaginably cold place. All matter, all life, all light, gone. This is the Big Freeze, a cosmic winter that never ends. It's a future where the universe, once aflame with the light and heat of countless stars, becomes a dark, silent, and frozen wasteland. A frigid, dark end devoid of light and life. But what if the universe's fate isn't to slowly fade away, but to be violently torn apart? Prepare for a cosmic catastrophe, the Big Rip. The Big Rip theory is as dramatic as it sounds. It's a hypothesis that takes the concept of the universe's expansion and turns it up to 11. The theory suggests that the expansion of the universe isn't just continuing, it's accelerating, and not just a little bit but to an unimaginable extent. Here's where things get really interesting. If this theory holds true, there will come a time when the expansion is so rapid that it will overcome the forces that hold everything together. We're not just talking about the gravitational forces that keep galaxies intact, or the electromagnetic forces that keep planets and stars together. We're talking about every force that exists in the universe. Imagine a universe where the expansion is so intense, it starts to rip galaxies apart. Stars would be torn from their orbits, hurtling into the dark void. Planets would be stripped from their stars, flung into the cosmic abyss. But it doesn't stop there. The very fabric of matter itself would be under threat. As the expansion continues to accelerate, even the strong nuclear forces that bind atoms together would be overcome. The atoms that make up everything we know, from the furthest galaxies to the screen you're watching this on, even your own body, would be torn apart. In the final moments of the Big Rip, every single atom in the universe would be ripped asunder. Sounds terrifying, right? But remember, this is just one theory among many. The Big Rip represents an absolute end, a universe that not only dies but is torn apart at its very seams. It's an end as dramatic as the universe is vast, and yet, it's a theory that's grounded in our current understanding of the universe. The same understanding that has led us to discover galaxies billions of light years away, and to explore the very edges of the observable universe. A cataclysmic end with every atom torn asunder, three very different possibilities, but which is most likely? Now that we've explored these cosmic ends, which one is the universe most likely to meet? To answer that, we must dive into the current scientific understanding and evidence related to the fate of the universe. It's a vast topic, filled with mind-bending concepts and theories. But don't worry, we'll try to simplify it as much as we can. Let's start with dark energy. It's a mysterious form of energy that's believed to permeate all of space. Scientists think it's the driving force behind the acceleration of the universe's expansion, and it plays a crucial role in predicting the universe's fate. Now, you might remember from earlier in the video that the Big Crunch theory suggests that the universe could collapse in on itself. This would require gravity to overcome the force of dark energy. However, current observations suggest that dark energy is not losing its strength over time. Quite the contrary, it appears to be constant or even growing. This makes the Big Crunch scenario less likely. On the other hand, the Big Rip theory posits that the universe will continue to expand at an ever-increasing rate, tearing everything apart, even atoms themselves. However, for this to happen, dark energy would need to increase dramatically over time. Again, current observations don't support this. So what does this leave us with? The Big Freeze, also known as the heat death. This scenario suggests that the universe will continue to expand, but at a steady rate. Over unimaginable timescales, stars will burn out, galaxies will drift apart, and all matter will slowly decay into radiation. It's a chilling prospect, but it's currently the one that aligns best with our observations and understanding of physics. However, it's important to remember that our understanding of the universe is evolving. Science is a process of discovery, and we're still uncovering the mysteries of dark energy and the universe's expansion. So while we may lean towards the Big Freeze, the universe keeps its secrets close. Who knows what we'll discover next? But what does this mean for us, the tiny inhabitants of this vast universe? Well, first and foremost, it's crucial to remember that the timescales we're discussing here are absolutely astronomical. We're talking about events that won't occur for billions upon billions of years. That's a time frame so vast it's hard for our human minds to truly grasp. Yet, despite the mind-boggling timescales and the fact that our species likely won't be around to witness the universe's ultimate fate, there's something profoundly important about understanding these possibilities. It's about more than just satisfying our curiosity, it's about understanding our place in the universe and the grand cosmic narrative. You see, we're part of a story that's been unfolding for nearly 14 billion years, and it's a story that will continue to unfold long after we're gone. We are, in essence, a fleeting chapter in the grand cosmic book. But here's the thing. Our chapter may be brief, but it's far from insignificant. By seeking to understand the universe and its possible fates, we're adding to the richness of the narrative. We're contributing to the grand story, not merely as passive observers but as active participants. So, while we may not be around to see how the story ends, we're playing a crucial role in telling it. After all, while we may not be around to witness the universe's end, it's a profound and humbling thing to understand the possibilities. In the grand cosmic story, we're but a fleeting chapter. Yet our curiosity and quest for understanding make us a vital part of the narrative.